Welcome to The Explainer. Today, we're talking about something pretty wild, bacteria that just don't play by the rules. We're going to go ahead and profile the microbial world's most wanted. So let's just dive right in. Picture this. You go to the doctor, you've got this nagging fever, a cough that just won't quit, but every single standard test comes back negative. What's going on? Well, the culprit might just be a mysterious class of germs that completely defies our usual methods of diagnosis and treatment. And that's exactly what we mean by atypical bacteria. They're the real outlaws of the microbial world because they just don't fit the classic mold. Today, we're putting a spotlight on the three most notorious groups, and believe me, each one has its own genius strategy for getting around our defenses. So let's meet our suspects. Our investigation is going to focus on three families of these very unusual germs: Rickettsia, Mycoplasma, and Chlamydia. Each one has a really unique way of causing trouble, basically by breaking a different fundamental rule of what it means to be a bacterium. All right, first up in our lineup, the Rickettsia. You could call them the hidden invaders. Their whole strategy is pretty simple, right? You can't catch what you can't see. And these guys are absolute masters of disguise, tiny little agents that get by hijacking our very own cells. So how do they do it? Well, their whole MO is what makes them so sneaky. Think of them as cellular hijackers. The key term here is obligate intracellular. It's a fancy way of saying they literally cannot survive on their own. They have to get inside our cells to multiply. On top of that, a lot of them are zoonotic, meaning they jump from animals to us, using vectors like ticks and fleas as their getaway car. Pretty clever, huh? And here's their game plan step by step. It all starts with a bite from an infected bug. The bacteria slip into the skin and they make a beeline for the cells lining our blood vessels. By multiplying inside those cells, they stay hidden from our immune system. Eventually, they burst out, ready to infect more cells, and that's what causes all the widespread inflammation. And this table, this is basically their rap sheet. You can see the pattern, right? You've got the group, like the typhus group, then the specific organism causing the trouble, and then the vector that's carrying it, like a flea or a louse. Probably the most infamous one in North America is Rocky Mountain spotted fever, part of the spotted fever group. And yeah, that one's transmitted by ticks. Okay, on to our next suspect, Mycoplasma. Now this one takes a totally different approach. Instead of hiding in our cells, it just changes its identity. That's why people call it the shapeshifter. So check out this comparison, because this is the whole story right here. A typical bacterium has this rigid, protective cell wall. Mycoplasma, it has no cell wall. None. And you might think that's a weakness, but it's actually its greatest strength. See, a ton of our best antibiotics, like penicillin, work by blowing up that cell wall. But if you don't have a wall, well, Mycoplasma becomes a ghost that those weapons can't even touch. And not having a wall has another effect. It makes Mycoplasma incredibly tiny and super flexible. In fact, these are the smallest known bacteria that can actually live on their own. And that flexibility lets them squish and squeeze into all sorts of different shapes, which is exactly where that shapeshifter nickname comes from. Now, the most famous member of this family is Mycoplasma pneumoniae. This is the one that spreads through coughs and sneezes, and it's the cause of what everyone calls walking pneumonia. It's often so mild that you don't even feel sick enough to stay home in bed, but you're stuck with this awful nagging cough that can go on for weeks. And that brings us to our final suspect, Chlamydia. This one is really interesting because it kind of combines the strategies of the other two. It hides inside ourselves and it changes its form. It lives this bizarre double life, which makes it an incredibly stealthy and successful pathogen. Okay, so this slide really shows its two-faced nature. When it's outside the body, it's in this tough, almost spore-like form called an elementary body. It's built for survival, built for transmission. But as soon as it gets inside one of our cells, bam, it transforms into what's called a reticulate body. And this thing is a replicating factory, just churning out hundreds of new elementary bodies to go out and continue the cycle. And the Chlamydia family is surprisingly diverse. You've got C. trachomatis, which most people know as a common STI, but other strains can also cause a really severe eye infection called trachoma. Then there's C. pneumoniae, which causes another type of atypical pneumonia. And then you get this really weird one, C. psittaci. You can actually get it from inhaling dust from infected birds, causing a disease known as parrot fever. So that brings up a really big question. If these bacteria are so weird, hiding in our cells, no cell walls, living double lives, how on earth do doctors figure out that they're the ones causing an infection? And yeah, it's a huge challenge. I mean, the very things that make these bacteria atypical also make them incredibly hard to find with our usual methods. You can't just take a swab, smear it on a petri dish, and expect these guys to pop up. It just doesn't work that way. Because of that, doctors need a whole different kind of toolkit. Instead of trying to find the bacteria themselves, they have to look for the evidence they leave behind. Think of it like this. Serology is like checking the security tapes. It's looking for the antibodies your body made to fight off the intruder. Then you have molecular tests, like PCR. That's more like dusting for fingerprints. It's hunting for the bacterium's unique DNA. Okay, so why does all this matter? Well, understanding these rule breakers isn't just some scientific curiosity. It is absolutely vital for treating people effectively and for public health in general. So let's just do a quick recap. These germs are true masters of disguise, right? They're either hiding inside our cells or just ditching their cell walls altogether. They cause a whole range of illnesses, everything from common pneumonias to really severe fevers. And they're a huge challenge for doctors because they just don't respond to a lot of our standard antibiotics. And really, that's the bottom line here. Atypical bacteria are a constant reminder that the microbial world is just full of exceptions to the rule. They represent the significant, challenging, and honestly fascinating part of infectious disease that forces us to take a completely different approach. They show us that in microbiology, you can never, ever assume anything. These three groups really show us that nature is just endlessly creative. It makes you wonder, right? What other microbial rule breakers are out there, just waiting to be discovered? And what new strategies are we going to need to come up with to stay one step ahead?